I'm Jennifer Healy, and I'm going to be explaining how plate boundaries work. Okay, so first off is think of the first time you saw a map. Most kids can look at a map, and when the first time they see a globe, it's not too hard to see that that Africa and South America look like they should be interlocking puzzle pieces. Well, scientists have believed this for a lot of years, but it wasn't until 1912 when a German meteorologist, Alfred Wegener, did a formal comprehensive theory of a continental drift. And basically what his theory was is that at one point that all of the land masses were one supercontinent. And that the supercontinent, he named it Pangea, and that stood for all, the word Pangea means all land. But he said that it all started out as one supercontinent many millions of years ago, and that over time it broke down and that they moved and formed what we see today. And so that was his theory of continental drift. One of the things that Wegener did not have is how necessarily that the land masses moved. One of his theories was it was possibly like how glaciers move. Well, let's fast forward a little bit. After World War II, because of the equipment that they had done for the war, oceanographers were able to do a lot more, taking this equipment and do a lot more extensive study of the ocean floor. And a couple of things that they were able to determine based on the ocean floor was, one, that they were able to just see all of the oceanic rift system that existed. And our textbook kind of gives an example of that, of thinking of it being a baseball, and that the baseball on the seam, so that all of this rift, oceanic rift, was through all of the major oceans. Also, by dredging the ocean floor, they were able to determine that the ocean floor was younger than they thought. They did not bring up anything that was more than 180 million years old, and it was much thinner. So based on this, by about 1968, theory of the plate tectonics theory was formed. Okay, so plate tectonic theory is generally accepted scientific theory that considers the Earth's lithosphere is comprised of a number of large tectonic plates which have been slowly moving for 3.4 million years. Okay, so right here I've got the map. You can see how the continents are outlined right there, but yet the plates are much bigger. And so also, if you think of it as a puzzle, this is how these plates move. So they're solid and they're rigid as far as that, but it's along all of these plate boundaries that they can move. Additionally, if you can see on this map, there's a lot of arrows. These arrows show that they're which direction that the plates are moving in. So Earth's outer layer, the crust, is composed of large plate-like sections of solid rock. These crustal plates essentially float on weaker layers of partially melted rock in the mantle below. Scientists believe that the convection circulation within the mantle helps continents to move. As heat from the Earth's innermost layer, the core, transfers the bottom layer of mantle rock, the rock warms, softens, and rises upward. This pushes cooler rocks down, and the cycle repeats itself. Okay, so based on this, we need to also understand how the plates are moving. Well, plates can move in three different ways, and this is very, very simplified. But the three different ways that they can move are divergent, convergent, and transform. So if you were to think of these as plates, if they're going to move apart like this, it's divergent. Typically when they move apart, they'll create a rift, a crust, or that type of a thing, depending on what type of a plate. The other way that they can move is when they move in towards each other. This is convergent. And then the last way that they can move is called a transform plate boundary. And that's when the two plates grind past each other without producing or destroying the lithosphere. Okay, so what I want to explain right now really quickly is a little bit more detail based on these different ways, and if you want to zoom in here about how the plates are going to move. So we've got right here continent to continent divergent. So this is where two continent plates are going to rip apart. When plates divergent occurs on land, the continental crust rifts or splits. This effectively creates a new ocean basin as the pieces of the continent move apart. So you've got it like that where they're pulling apart. Next one is ocean-ocean divergence. Oceanic divergent boundaries are spreading boundaries when new oceanic crust is created to fill in this place as the plates move apart. So when these two plates move apart like this, what happens is there's more crust, or this ocean crust is formed, and eventually it can form mountain ranges. Eventually these mountain ranges can rise above the water to form islands. Then we've got the continent transform, and this is again where transform is again where they slide apart. So transform boundaries, the grinding action between the plates of the transform plate boundaries result in earthquakes, large lateral displacement of rock, and a broad zone of crustal deformation. Okay, so these are when they're all pulling apart. Now let's start talking about the convergence when they're pushing together. This is when two ocean plates push together. So in ocean-ocean convergent, two oceanic plates converge or collide. The denser plate subducts into the asthenosphere below the convergent zone and forms a trench. So right here it goes under and forms a trench. An example of this is the Mariana Trench, which is the deepest part of the ocean. On this part right here, you've got the ocean-continent convergent. In this particular case, when it's oceanic continental convergent boundaries occur, when a tectonic plate primarily composed of oceanic lithosphere collides with the plate of continental lithosphere. An example of an ocean-continent convergent boundaries are the Naztec plates under South America. So right here, what you've got, where this was, is what created the Andes Mountains. And then lastly, we've got continent-continent convergent. And continent-continent convergent is formed between two continental plates. When the plates converge, sediments are squeezed and upward thrust between the plates, and these squeezed sediments appear as fold mountains along the plate margins. An example of this is the collision of the India plate right up here with the Eurasia plate, and this is what created the Himalaya mountains. So the theory of plate tectonics helps reinforce the continental drift theory, and they both feed off of each other, and they both support each other. This was obviously a very simplistic demonstration, but hopefully it gives a better understanding of how plate tectonics work and how the plates move. Thank you.